presenting about the current and future exposure of the Canadian Wildland-Human Interface and population to wildland fire. And it will be a bit different from the preceding presentation in the sense that it will focus a bit less on ecological aspects, but more on the relationship between the forest and people that live into the forest, as it matters in terms of wildland fire exposure. So we have a number of products that were produced by the Canadian Forest Service that allow us to do a number of things. And we've been using the annual disturbance map that was produced by Luc Guindon to locate the fire that have occurred in the country from 1985 to 2015. And we've used also the forest cover properties, so basically the composition of the forest and the age of the forest, to assess what was the type of forest that was burning in the fire that have occurred over that period. And by combining the conifer content and the stand age of all the fires that have occurred, we were able to show that fire across the country does not burn the forest composition randomly. So in fact, we had classified the forest in young and old forest, and in terms of composition between deciduous and coniferous. And what we showed is that the young deciduous forest had burned 6 times less than what would be projected if they were burning randomly, whereas the older forests that were in coniferous were burning 2 times more than expected if there was a random selection in terms of what is burning in the Canadian fire. So if we report that on the land base, you can see here that we have pixelized the exposure in terms of fire return interval that goes from very short fire in red to very long fire return interval in green. And you can see, for instance, if you look at the Quebec regions, that there is variation in the region where some pixels, depending on the composition and the age, are less likely to burn as compared to the regional area. So we use that information to define the current exposure of the land base, of the forested land base in the country. We then obtained information on the location of what we call the human interface. So basically, that's the area that is either inhabited by human, or where we see infrastructure and industries, but that are located close enough to forests that are likely to burn if there's an ignition. So that's what we call the wildland-human interface, and it's subdivided in 3 types. So there's the wildland urban, so mostly the communities, and you can see that they are located in the southern area of the country. There's also the industry and the infrastructure, which tend to extend a bit more in the north. And if we look at the combination of the exposure, so the return interval of the fires and the wildland human interface, you can see that there's area in the country where short fire return interval are present, and they are mostly located in regions where we have industries and infrastructure, which are elements that we spread, let's say, in a fire-prone landscape without considering the fact that the fire can occur in the forest. So if you look at the current element on this graph, you can see the cumulative area that is exposed to relatively short fire cycle. So we estimate that 250 years is relatively short, and you can see that 20% of the wildland-human interface is currently exposed to a short fire cycle, and about 5% of the interface is currently exposed to a fire return interval below 100 years. As we all know, the climate change will increase fire activity across the country, and here you have the progression that is projected under the RCP 8.5, and you see that the annual area burn is expected to increase as compared to what was observed between 1961 and 1980. So at term, the area burn would increase as much as 4 times what we see currently. So here it's just the same image as before. So the area of the wildland-human interface exposed to short fire cycle, and you can see that with the projection of future fire, the return interval is expected to decrease for a number of area, but at term you can also see that there would be a larger area that would be exposed to short fire cycle. So just remember here that it's a static view of both the interface and the composition of the forest. We have not changed both of these areas, so basically it just shows how exposure is expected to change if the forest and the interface remain the same. But you can see here that so you have the current and the 3 future period, and you can see that by the end of 2100, there would be about 45% of the wildland-human interface that would be exposed to relatively short fire cycle, fire return interval, sorry. So now we can ask, where are the populated place located within that interface? So here you have the location of the important human settlements, and in orange here you have the population that are from native peoples that live on reserve. So the population of Canada in 2011 was 30.5 million people, of which about half was living in the forest, but about 20% is living within the wildland-urban interface. But if you look at the First Nation on reserves, they only represent 1.1% of the population in the country, but they do represent almost 3% of the population that are on the wildland-human urban interface. So they are much more exposed to fire. And when we look at the current exposure, you can see that about 20% of the reserve inhabitants are exposed to fire return interval below 250 years, and of which 9% or so are exposed to a fire return interval below 100 years, which contrast with the other population that don't live on reserve, where 5% of the people that live within area that are susceptible to fire are located in regions where the fire return interval is below 250. So for the future, if we look at term at the end of the current century, between 32 and 38% of the reserve inhabitants would be exposed to short fire cycle, of which 20 to 28 would be exposed to return interval below 100 years. And again, it shows that the exposure of the First Nation population that live on reserve is a lot higher than for the rest of the population. So this work was the first exposure assessment of the area and population exposed to short fire return interval. As I said, the fuel, the population, and the interface are static, and we only projected what would be the change in fire regime. But there are people in our lab that are currently working to assess what would be happening if we consider the change in the fuel population and the expansion, the potential expansion of the interface. But still, the work allowed to raise awareness of the current exposure of the area. And as a matter of fact, it is rare that in planning development of the infrastructure or the industry in the country that wildfire is considered. It also allows to think about potential mitigation strategy. And I just want to end showing some results here that when we take into account the fact that old coniferous forest has a higher tendency to burn than young coniferous forest, it shows that it can reduce or temper the impact of the projection that we've seen when we consider climate only. So if we project future change by considering both climate change and vegetation, the future area burn may decrease. So it's just an example of the type of things that can be done to protect communities or infrastructure or industries. Again, that wildfire, it could be the use of deciduous trees, for instance, around communities to reduce the risk of fire or to help the firefighters to extinguish the fire around these communities. So thank you, and I can take questions if you have some.
Thank you very much, Sylvie. That was awesome. Est-ce qu'il y a des questions? Use the chat, section clavardage. Oh, Yves Bergeron has a question.
Hey.
Yes, Sylvie, when I look to the graph, the curves start to increase 25-year fire cycle or something like that. So don't you think that there would be kind of negative retroaction that this kind of fire cycle or fire return interval will not be possible in the future?
Yeah,
I mean, we're not California. I mean, for boreal forest.
Well, there will be, of course, a retroaction in the sense that if the stands burn too often, there won't be any fuel left for the future burn. So that's one element to answer your question. The other element is that in our projection of the future fire, we have not considered the fact that vegetation can be more prone to burning or not burning depending on the age and composition. So the inclusion of that into even the projection of future fire is important, and we're actually working on that. So I'm not sure if this was your point.
Yeah, that was my point. Thank you.
Do we have other questions?
Please don't hesitate. One last note that I want to say is that actually the Midi de la Foresterie is going to be happening tomorrow. Sorry about that, I just found that out right now. So the presentation by Franck Bernerger is going to be shifted tomorrow at 4 UTC. Are there any questions for Sylvie? Because this would represent the last presentation of the day officially. For this Congress. Because I know you're all working by Zoom these days, so you're very courageous to do all that. Est-ce qu'il y a d'autres questions pour Sylvie? Sylvie, I have several questions, but the one question that I wanted to ask was on the very last slide. Why is it that on only in very short spaces of time, there's some very large increases all of a sudden? So they're like kinks in the curve. What is it? Is it that there's a particular climate during those 5 or 10 years that's favoring increased fire activity?
I think you're referring to the last graph, which shows the difference between projection with
Yes.
and without consideration. I just think that the way the projection were done was by period. So there's a bigger change in increase when the 2040, 2070 changes. So that brings a blips into it. So it's an artifact of that, I believe.
And do you think that it's related to some kind of atmospheric oceanic teleconnection that we could have, for example, a warming of the Gulf Stream that leads to increased fire during that period, or something related with the Arctic oscillation?
I cannot say because I don't recall how we modeled that.
Yeah, I had the discussion with, so there was a big work that was done as well by Kirschmeyer and Young about the big fires that happen in Western Canada. And one of the big questions that I asked was like, well, do we account for teleconnections in the climate change model? And his answer was like, yes. So it's possible that so in the climate model, it's just a phenomena from a type of teleconnection where there is a drought phase that is associated with increased drought and thus associated with increased fire frequency during that particular time period. I'm thinking that that's what's going on.
Yeah, I'm not sure. The thing I'm not sure about is that if the graph I showed is for a particular region of the country, or is it something that is done across the country, so where, you know, connection would be taken into account, but would be different from the eastern to the western part of the country.
Oh, and so potentially there could be a dominant effect from, say, the Pacific decadal oscillation over other types of oscillations, for example.
Yeah, so I'm really not sure how we did that. So
no worries. It's really cool research, though. Thank you so much for participating in this work.